Hello everyone. In this video, we will deal with some problems related in computing the percentiles for continuous insurance. First, consider the whole life insurance of 1. The present value random variable z equals e to the power minus delta times tx. Z is a decreasing function of tx. Let z equals to a particular value, say eta. The event z less than or equals eta can be rephrased in terms of tx. Tx is greater than or equals to a particular value. Let's consider the probability that z is less than or equals to eta. And here p corresponds to the 100 times pth percentile of z. Rewrite the probability statement z in terms of here tx. Solving for tx here, we get the probability that tx is greater than or equals to this expression. Therefore, the event z less than or equals to eta corresponds to or is equivalent to tx greater than or equals to minus 1 over delta times the lateral log of eta. And this probability statement can be written as this. That is, the CDF of tx at this particular value is the 100 times 1 minus pth percentile of tx. We can relate fz and f of tx. The 100 times pth percentile of z is equivalent to the 100 times 1 minus pth percentile of tx. That is, if we want to get the 100 times pth percentile of z, we can start with finding the 100 times 1 minus pth percentile of tx. And then with this value of tx, we can get the value of z, because z equals to the e to the power minus delta times tx. Let's take a look at an example. A whole life insurance of 1 on an individual at age 30. Benefits are payable at the moment of death. Constant force of mortality 0.01, force of interest 0.05. We want to get the 85th percentile of z. All right, to get the 85th percentile of z, this is equivalent in getting the 15th percentile of T30. So we want to get the CDF value of T30 equals to 0.15. The CDF of T30 is in fact NQX here, so that is TQ30 equals to 0.15. The expression for TQ30 with constant force of mortality 0.01, we get this expression. Solving for t, we get t equals 16.25. That is, the 15th percentile of T30 is 16.25. This value of t corresponds to the 85th percentile of z. When we plug in tx equals to 16.25 in this expression. With delta equals 0.05, we get the 85th percentile, 0.4437. And in fact, we can combine this into a single step. The CDF of z, we write z in terms of tx. And then this probability statement corresponds to npx, where n here is the negative of the lateral log of z over delta. We work with this example. The 85th percentile of z, we have this probability statement equals to 0.85. And then we want to solve for the value of z such that this expression P30 equals 0.85. Constant force of mortality. So NPX, this is e to the power minus mu times the expression. Solving for z, we get the same answer, 0.4437. This is the 85th percentile of z. How about the n-year term insurance? This is the PDF of z. The probability that z equals 0 corresponds to the event that the probability Tx is greater than n, which is NPX. That is, for the 100 times pth percentile of z, if p is less than or equals to NPX, then z is 0. For the n-year endowment insurance, the minimum value of z is e to the power minus delta times n. The corresponding probability is NPX. So when p is less than or equals to NPX, the value of z here is e to the power minus delta times n. Let's take a look at an example. A 20-year term insurance of 10 issued to an individual at age 30. Death benefits are payable at the moment of death. Mortality follows the Morpheus law, omega 120, delta 0.06. Calculate the 40th percentile of z. All right. One approach, we get the probability that z is 0, which is NPX. Under the De Morpheus law, and n equals 20, 20-year term insurance, we get 20p30, 0.7778. That is from the 0th percentile to 77th percentile, or 77.78 percentile, z is 0. And now we want to get the 40th percentile of z, then z is 0. Another approach, we start with the expression that z equals to 10 times e to the power minus 0.06 t30. And keep in mind that t30 is less than or equal to 20, or else the value of z will be 0. To get the 40th percentile of z, this is the same as getting the 60th percentile of t30. Work out the expression that the CDF at the value t is 0.6. Under the De Morpheus law, TQ30 equals to this expression, the 60th percentile. This expression equals to 0.6. Solving for t, we get t equals 54. But this is a 20-year term insurance, and now t is 54. T should be less than or equal to 20. That is, the individual here dies after the 20-year period in order to have the 60th percentile of t30. Since t is greater than 20, we get the answer, 40th percentile of z is 0 here. All right, another example. A 15-year term insurance of 200 issued to an individual at age 45. Death benefits are payable at the moment of death. Suppose the density function for T45 is given by this expression. And then we have the interest rate 8%. Calculate the 88th percentile of z. The 88th percentile of z, the expression for z, 200, and then e to the minus delta delta is the lateral log of 1 plus I, and then times T45. And T45 is less than or equals to 15 because we are considering a 15-year term insurance. This is equivalent in finding the 12th percentile of T45. We are given a density function. So we want to get the value of eta such that the CDF at eta is 0.12. We set up the integral. The integrand is the density function equals to 0.12. Solving for eta, we get eta equals 11.3063. All right, so this value is less than 15. To get the 88th percentile of Z, we plug this value of eta for T45 in this expression. And then we get the answer, 83.7779. Another example. For a 10-year term insurance of 500 issued to an individual at age 64, given that the death benefit are payable at the moment of death, mortality follows the given life table. Delta is 0.06. Deaths are uniformly distributed over each year of death, over each year of age. Calculate the 96th percentile of the present value random variable for this insurance. All right, to get the 96th percentile of Z, where Z equals 500 times e to the power minus delta, which is 0.06 times T64. And this is a 10-year term insurance. T64 should be less than or equal to 10 here. This is equivalent in finding the 4th percentile of T64. All right, we want to get the value of T such that the CDF of T is 0.04. Given the life table, the CDF of T64 equals to L64 minus L64 plus T over L64. And we get L64 here. And we can solve for L64 plus T, which is this value. And this value is between x equals 69 and x equals 70. We need to get the value of T. Deaths are uniformly distributed over each year of age, UDD. Using interpolation, we can get the value of S. L69, L70, and then we can solve for the value of S. This is not the value of T. So S is 0.7696. This corresponds to the life table function L at age 69.7696. From this, we can get the value of T. 64 plus T equals to 69.7696 here. And we get T equals to 5.76969. All right, so that is in this expression, T64 equals to this 5.76969. And therefore, we can get the 96th percentile of Z, which is 353.69. Next, we move on to deferred insurance. For the n-year deferred insurance of 1, we get this CDF graph for Z, and we have the PDF here. The probability that Z equals 0 is NQX. That is, to get the 100 times pth percentile of Z, if P is less than or equals to NQX, then Z is 0. What if P is greater than NQX? The CDF equals to the probability that Z equals 0, which is NQX, and then plus the probability that Z is between 0 and Z. All right, so for deferred insurance, the CDF of Z equals to NQX, and then plus the probability that TX is greater than or equals to this expression. So there are two parts. Corresponds to the CDF for deferred insurance. All right, let's illustrate this with an example. A 10-year deferred insurance of 1 issued to an individual at age 40. Death benefits payable at the moment of death, mu 0.01, delta 0.05, and we want to get the 75th percentile of Z. First, we get the probability that Z is equal to 0, which is 10^40. Upon calculation, we get the corresponding probability. The 75th percentile of Z, this is a deferred insurance. So remember the CDF here, two parts. And therefore, the 75th percentile of Z equals to the probability that Z equals to 0, which is calculated as 0.095, and then plus the probability that Z is between 0 and Z. That is, the probability that Z is between 0 and Z is 0.75 minus this value. And upon calculation, we get 0.6548. That is, we want to get the probability that this expression e to the power minus 0.05 t40 is less than or equal to Z. This probability is 0.6548. We write this expression in terms of t40. So we can get this expression. Solving for the value of Z, and we get the answer. Z equals 0.1204. All right, that's it for today's video. Thank you for watching and see you in the next video.